Hello, Math 2200, Discrete Mathematics. Professor Wenson here again to talk with you about ZyBooks Section 1.3, titled Conditional Statements. So these are this is going to start off with the if-then statements, if P, then Q, where P and Q represent propositions. Okay, so section 1.3 conditional statements, and like I did with section 1.2, I'm not going to read every little word to you. I'm not going to do everything. I'm just going to start things off and hopefully, give you enough information. To guide you through this. All right. The conditional operation is denoted with an arrow symbol, a single arrow from left to right. The proposition P implies Q. Now, I'll say P implies Q a lot. Is read if P then Q. So P implies Q, or if P then Q. The proposition if P then Q is false if P is true and Q is false. All of the cases, if P then Q or P implies Q is true. A compound proposition that uses a conditional operation is called a conditional proposition. A conditional proposition expressed in English is sometimes referred to as a conditional statement, as in, if there is a traffic jam today, then I will be late for work. That's a conditional statement, an if-then statement. In if P then Q, the proposition P is called the hypothesis, and the proposition Q is called the conclusion. And the truth table is given below. And again, I'll write this out for you. Now, I want to explain something first. We'll come back to the truth table. Well, let me write the truth table out first. I'm going to do this on paper like I did with all the other truth tables. Okay, so this is a conditional statement. The if P then Q, right? Where again, P is called the hypothesis, Q is called the conclusion. So truth tables, right? There are only two propositions here, so there are going to be 4 rows in the truth table. And you've seen me make these now. All 4 possible combinations of truth values for 2 propositions. Then if P then Q, or again, P implies Q. If the hypothesis is true and the conclusion is true, then if P then Q is considered a true statement. If the hypothesis is true and the conclusion is false, this is the only time the if P then Q statement is considered a false statement. And I'll explain this, why that's the only time it's considered false. I'll read you their explanation, in a minute. If the hypothesis is false and the conclusion is true, then the conditional statement if P then Q is considered a true statement. And if the hypothesis is false and the conclusion is false, this might be the trickier sounding one, then the conditional statement if P then Q is considered a true statement. All right, so again, why is that? All right, so let's move on. So you got that here. All right. So again, like I said, I'm not going to read a lot of stuff, but I want to get this part out of the way too. A conditional proposition can be thought of like a contract between 2 parties, right? Like the hypothesis and the conclusion. All right. So think about this statement. If you mow Mr. Smith's lawn, then he will pay you. So P, Let's see. P is the statement, you mow Mr. Smith's lawn. Q is the statement, he will pay you. And this is a if P, then Q, a conditional. Now, if you think about when is the contract broken, when does Mr. Smith lie to you? And if Mr. Smith lies to you, if Mr. Smith breaks his contract to you, then we'll consider the conditional statement a false statement, a broken contract. If Mr. Smith does not lie to you or does not break his contract with you, doesn't deceive you, then we'll consider the statement true. The contract is still unbroken. So look at this little table here. So suppose P is true. You actually do mow Mr. Smith's lawn. If Q is also true, he pays you, then the contract was fulfilled, right? The statement is if you mow the lawn, then he will pay you, and both of them are true. You mowed the lawn, he paid you. So the contract wasn't broken. We'll consider the statement, not a lie. Consider the statement true. Now, if the hypothesis is true, if P is true, if you mow the lawn, but the conclusion is false, Q is false, Mr. Smith does not pay you, well, then this is a lie. This statement is a lie. The contract is broken with Mr. Smith. You mowed his lawn, but he did not pay you. So he broke the agreement, broke the contract. So there's a lie indicated here. So that's why that situation, the statement is considered false. Now in the other two statements here, the other two parts of this table, when the hypothesis is false, P, the statements you mow Mr. Smith's lawn, if this is false, if you don't mow Mr. Smith's lawn, then the contract can't be broken, no matter what happens. If the hypothesis is false, the statement can't be broken, can't be considered a lie. Right? If you don't mow the lawn and he still pays you, nothing changed. He wasn't lying to you. He said he'd pay you if you mowed the lawn. He didn't say anything about paying you if he didn't mow the lawn. So if he pays you when you didn't mow the lawn, great. Nothing was broken here. Your agreement with Mr. Smith was not broken. So that's still considered a true implication, a true statement. Same thing here. If you don't mow the lawn, the contract with Mr. Smith is not broken. So it's still a true statement, even if he does. If you don't mow the lawn, he doesn't pay you. That's what you expect, right? Right. So if the hypothesis is true and the conclusion is true, the whole thing's true. The implication is true. If the hypothesis is true and the conclusion is false, that's when you have a breach of contract. That's when the conditional statement's considered false. And then if the hypothesis is false, it doesn't matter what the conclusion is. The conditional statement isn't broken. It would be considered true, no matter what. So in both cases, when the hypothesis is false, you got truth. All right. So hopefully that explanation made sense. And people have a tricky time with this one. Just know that it's only a conditional statement is only false when the hypothesis is true, but the conclusion is false. Okay. All right. So let's go through it now. I'll just do one or two of these. All right. So again, you're going to fill them all in. Right? All right. Each question has a proposition P that is a conditional statement, an if-then statement. Truth values are also given for the individual propositions contained in the conditional statement, right? The hypothesis and conclusion. Indicate whether the conditional statement P is true or false. So the conditional statement, right, this statement here, is if it rains today, I will have my umbrella. Then, you could throw the word then in there. Then I will have my umbrella. That's a conditional statement. The hypothesis is, it rains today. The conclusion is, I will have my umbrella, or I have my umbrella. Then they state, it is raining today. So the hypothesis, it rains today, is true. I do not have my umbrella. So the conclusion, I will have my umbrella, is false. So I have a true hypothesis, a false conclusion. That was the only case when a conditional statement was false. Okay? I'll just do the other one, the number 2 here. All right, so the statement, if Sally took too long getting ready, then she missed the bus. Hypothesis, Sally took too long getting ready. Conclusion, she missed the bus. Now the statements here, to tell me the truth values of these, Sally did not take too long getting ready. So the hypothesis, Sally took too long getting ready, is false. So this is going to be the statement P. That conditional statement is a true statement. Remember, when the hypothesis is false, the contract, the statement isn't broken. So it's considered true. So it doesn't matter if Sally missed the bus or not. The hypothesis was false. Since the hypothesis is false, the conditional statement is considered true. And you do the third one. Now, this is where it gets a little tricky as well. There are many ways to express the conditional statement, if P, then Q, in English. P arrow Q. All right, so really pay attention to these, as you're going to be asked about them in your assignment, as well as the participation activities and whatnot. So the proposition P here is, you mow Mr. Smith's lawn. Proposition Q, Mr. Smith will pay you. Every single one of these, all 7 of these lines here, is another way of saying P arrow Q. This P arrow Q. So every single one of these is symbolized P arrow Q. So if P, then Q. If you mow Mr. Smith's lawn, then he will pay you. That's if P, then Q. P arrow Q. As you saw in some of the statements up here, in the participation activity, if P, comma, pause, Q. If you mow Mr. Smith's lawn, he will pay you, right? Then he will pay you. It's exactly the same statement. Q, if P, Mr. Smith will pay you if you mow his lawn. This is the same thing as the first statement. Every single one of these is the same meaning as the first statement. So this would be P arrow Q again. I've already said the word implies several times now. P implies Q. Mowing Mr. Smith's lawn implies that he will pay you. Has the same meaning as if you mow Mr. Smith's lawn, then he will pay you. P, only if Q, has the same meaning as if P, then Q. Right? You will mow Mr. Smith's lawn only if he pays you. That's the same thing again as if you mow Mr. Smith's lawn, then he will pay you. P is sufficient for Q. So, P happening is sufficient for Q to happen. That's the same as if P, then Q. And Q is necessary for P. That means if Q doesn't happen, P won't happen. But still, saying that Q is necessary for P is the same as saying if P, then Q. So pay attention to the order that things come into. Right, in a couple of these, the Q was before the P, but you would still symbolize it P arrow Q. So pay attention to the wording and the order of the propositions. Right. So let's look at this next activity. Again, I'll just do the first couple. So P is the statement, I will share my cookie with you. Q is the statement, you will share your soda with me. Select the symbol that would match, right? Select the conditional statement that has the same logical meaning as the English sentence given. If you share your soda with me, then I will share my cookie with you. So this is an if-then, right? So P here, you share your soda. So this is Q actually. So if Q, then P. So this is Q implies P. Q arrow P. 2. Me sharing my cookie with you is sufficient for you to share your soda with me. Now sharing cookie with you, that's statement P. P is sufficient for Q. Looking back up here, P is sufficient for Q. That's exactly the same as P arrow Q. It's one of these. So this is P implies Q. And you can do the third one. All right, so I'm going to do the challenge activity. There are 5 of these. I'm not going to do all 5. Maybe I'll do 2 or 3 of them. And you're putting symbols in, but now you have the arrow symbol showing up. You have negation, and, or, and then the arrow symbols. So P is the weather is bad, Q is the trip is canceled, R is the trip is delayed. Here's the proposition we're given. If the weather is bad, then the trip will be delayed. So that's whether the weather is bad is the hypothesis, P. It's an if-then statement, so P implies, if P then, and the trip will be delayed, R. P implies R. Move on to the next one. The weather is bad is a sufficient condition for, is sufficient for the trip to be canceled. So the weather being bad, that's P. Remember, this is sufficient for, it's like the arrow. P, the weather is bad, arrow, trip is canceled. So P implies Q, P arrow Q. The trip is delayed and the weather is good. So the trip is delayed, R. And, just simply and, there's no implication here, there's no conditional statement here, there's no if then. Just and the weather is good. Now the weather is good is the negation of the weather is bad. So this is R and not P. Alright, and you can do the last couple. And again, now you might be seeing things in different orders than I am. There's lots of these challenge activity problems. So you might see different problems than I did here. Just pay attention to the wording. And if you're confused on what goes where, remember all these up here are equivalent when you're talking about implications. All right, next part. All right, so now that we have a conditional statement down, right? If P, then Q, P arrow Q, P implies Q. There are 3 other statements that are related to a conditional statement. So 3 conditional statements related to P arrow Q, right? P implies Q, are so common that they have special names. The converse of P implies Q is Q implies P, right? So for the converse, you're just switching the hypothesis and conclusion. P arrow Q, the converse, Q arrow P. The contrapositive, I'll do the inverse next because the contrapositive puts them together. The inverse of P implies Q is not P implies not Q. So for the inverse of a conditional statement, you just negate, do the negation of the hypothesis and conclusion. All right, so not P. P arrow Q, inverse, not P arrow, not Q. All right, then the contrapositive of P arrow Q, of P implies Q, is not Q arrow, not P. So for the contrapositive, you're doing both of these converse and inverse at the same time. So if I have P arrow Q, you can negate them, make it not P implies not Q, that would be the inverse, and then switch them. Switch the not P and not Q, make it not Q, arrow, not P. So the contrapositive is the inverse of the converse or the converse of the inverse. All right, you negate them and switch, or switch then negate. Okay? So an example here. So here P arrow Q, P implies Q is this statement. If it is raining today, then the game will be canceled. The converse is just switch, it is raining today and the game will be canceled. So you have if the game is canceled, then it is raining today. The inverse is just negate them. So if it is not raining today, then the game will not be canceled. That's the inverse. And then you can take the converse and do the inverse of the converse, or take the inverse and do the converse of the inverse and get the contrapositive. Alright, so again, contrapositive is negate them, negate the hypothesis and conclusion, then switch them. Do both. So if it is, it is not raining today, the game will not be canceled, but then switch them. So if the game is not canceled, then it is not raining today. Alright. So let's look at some examples. So consider the conditional. This is a short one. I'll just do all three. If he studied for the test, then he passed the test. So the hypothesis is, he studied for the test. The conclusion, he passed the test. The converse, would you just switch these? So if he passed the test, then he studied for the test. That is, now for this kind, you just kind of move it down. Right? Move the blue stuff down to the empty blank. The inverse is just take the conditional statement that you started with, negate the hypothesis and conclusion. So if he did not study for the test, then he did not pass the test. Right? You do the not hypothesis, not conclusion. So if he did not study for the test, then he did not pass the test. That's the last one. And of course, the first one's the contrapositive, where the contrapositive, and get to knowing these words, please. You negate them, then switch them, or switch them, then negate them. So I'll do the negate them. He did not study for the test, then he did not pass the test, and then switch those. So if he did not pass the test, then he did not study for the test. That's the contrapositive. Again, just move it down to the blank. All right. So again, get to knowing those really, especially the word contrapositive, because we're going to see later when we talk about logically equivalent statements that a conditional statement and its contrapositive are logically equivalent. They'll always have the same truth value, but not the converse or the inverse. A conditional statement won't always have the same truth value as its converse. Same thing as a conditional statement won't always have the same truth value as its inverse, but it will always have the same truth value as its contrapositive. All right, the biconditional. Now this is you'll see this double arrow, an arrow going in both directions. So if P and Q are propositions, the proposition P if and only if Q. P if and only if Q is expressed with what's called the biconditional operation and is denoted as P and then this double arrow Q, right? An arrow going back and forth, a bidirectional arrow. The proposition P if and only if Q is true when P and Q have the same truth value, and is false when P and Q have different truth values. So I'll make the truth table for that on paper. Okay, so this is the biconditional. New marker here. So P, if and only if Q. All right, this is now sometimes this is abbreviated as IFF. You might see IFF in some texts. That means if and only if. So that means you're going in both directions. All right, so if P then Q, and if Q then P, really. So the truth table. So you got the two propositions. So there's going to be 4 rows, and I'll set those up again. All the possibilities. All right, and then we're making a truth table, truth column for P, if and only if, right? Double arrow Q. A statement like this is going to be true only when P and Q have the same truth value. So in the first row, you see how P and Q are both true. So in that case, the biconditional statement is considered true. And in the last row, P and Q are both false. They have the same truth value. And when the two statements have the same truth value, the biconditional is considered true. And then all other times when the truth values aren't the same, right, true and false, false and true, the biconditional is considered a false statement. So we have true, false, false, true there. All right? Let me give that to you here. All right, now compound propositions. Now this is just like back in the last section, section 1.2, when you're evaluating a compound proposition, right? Finding the truth value of some statement. This just tells you the order of operations again, right? So if parentheses are not used, then you remember the order of operations from last section was do the nots first, the negations, then the ands, then the ors. Those should be applied before the conditional or biconditional. Right? So you do conditionals and biconditionals after the nots, ands, and ors. Okay, but for the most part, parentheses will be used to indicate which operation should be used first, and that's a good practice. Right? So again, I'll leave the animation for you to watch. All right, so here I'm going to write these out, and I'm not going to do all 6 of them. I'll do a few of them though. All right. So we're given the following information. I'm given that proposition P is some true statement. Proposition Q is also a true statement. Proposition R is a false statement. And now I have a proposition called S, which is also a false statement. We're given these truth values. And we're asked to determine the truth values of the following. So the first one I have S implies Q, or if S, then Q. Right. So replacing with the truth values, we have a false statement implying a true statement. Remember, this is going to be a true statement. Right? Remember, I mentioned this earlier, right? You have a hypothesis and a conclusion when you have this single arrow. If the hypothesis is false, the conditional statement is considered true. It doesn't matter what the conclusion is. Remember that. So that's a true statement. And I'm not going to do all of these, just a few of them. Next one, we have in parentheses R, if and only if, S, right, the biconditional, and Q, right, the conjunction and symbol. All right, so I've got parentheses around this. I'll do that first. Let me put in the truth values. So we have in parentheses, we have a false statement, if and only if S is also false. Right. And then Q is a true statement. Right, so I'm doing the biconditional first. That's in parentheses. And there's only one operation in there. It's just the biconditional. And I just got through talking about that one, right? Remember, a biconditional statement is true only when both the statements have the same truth value, which these do. They're both false. So this biconditional statement is considered a true statement. And then we have the and then another true statement, and true and true. Remember, a conjunction, an and statement is true when both statements are true only, right? And false otherwise. So this is also true. All right, so hopefully that was a good couple examples there. I'll do one more. Right. Third one, I have a if Q, then not R. Right, if Q, then not R. A regular conditional, not a biconditional. Hypothesis, conclusion. All right, so the hypothesis Q is true, implies, and then the conclusion is not R, not a false statement. I mentioned the order of operations. Right, if there's no parentheses like there aren't here, you do the negations first. So I'm doing that not false first. So we have true implies not false is true. And then there's only one operation left, the implication, the conditional. And the hypothesis is true, the conclusion is true. So this whole statement is true. So far everything's true. Remember, the only time a conditional if-then statement is false is if the hypothesis is true and the conclusion is false, but that didn't happen here. So we got a bunch of trues for my first three, right? True, 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 and then you can do the last three. All right, and then we got some truth tables to fill in. That looks like about it. All right, so I'll do a couple of these. All right, so I've already done the truth table for P implies Q. All right, when both are hypothesis and conclusion are true, the conditional is true. That's the only time it's false, right? When the hypothesis is true, the conclusion is false. I got F there. And then when the hypothesis is false, it doesn't matter what the conclusion is. The whole statement's considered a true statement. So TT. Right? All right. Now this is a biconditional. We have not P, if and only if, not Q. So remember, this biconditional is only going to be a true statement when both, not P and not Q have the same truth value. Now you can write these out if you wish by hand. But let's see, not P would be false, not Q would be false, so they're the same truth value. This is a true statement. Put a T there. Not P would be false, not Q would be true. They're not the same truth value. So we have a false biconditional, F. Not P would be true, not Q would be false. They're not the same truth value. So again, false, F. Right? And then not P would be true, not Q would be true. They're both true. So you have a biconditional that is true, right? The biconditional is true when both have the same truth value. Okay, and I'll leave the last three for you guys to do. And you can read the last example as well. All right, I'm not going to read the examples to you. And then the additional exercises, as you've seen, are showing up in the assignments, right? The assignments I'm having you do on paper and then submitting to me as a file. And not, and you can see the solutions, right, if you want, but I would recommend trying to do them first, before you look at the solutions and see how you did. It's the only way you're going to learn anything, not just looking at the solutions. And yeah, and not every single assignment is every single exercise is assigned. So I would recommend even doing the ones that I didn't assign just for extra practice and extra material. Get used to the material a little bit more. Okay. So that's all for section 1.3 on these conditional and biconditional statements. The inverse, converse, contrapositive of a statement as well. And thanks for watching.